Today we are going to talk about Coulomb's law versus Biot-Savarts law. As we know that Coulomb's law is related to force between two charges and Biot-Savarts law is related to the magnetic field due to the current carrying conductor. Both are long range. Both are conservative. Conservative means independent of path. That the force between two charges independent of path, then we call it as a conservative. So both Coulomb's law and Biot-Savarts law are conservative in nature, and long range means there is no physical contact between the two actors. That is no physical contact between the two charges, or there is no physical contact between the conductor and the point where we find the magnetic field. Second point, both Coulomb's law as well as the Biot-Savarts law, they follow inverse square law. In Coulomb's law, the force between two charges inversely proportional to square of distance between them. Similarly, in Biot-Savarts law, the magnetic field produced due to current element is inversely proportional to square of distance between them. Thus, Coulomb's law and Biot-Savarts law both depend inversely on the square of distance from the source to the point of observation. Point number third, Coulomb's law applicable for static charges and Biot-Savarts law applicable for vector source. In Coulomb's law, there are the two charges, one is the Q1, another is the Q2, and both are static charges. In Biot-Savarts law, we have the current element. This is the current element. This is the current element. Current element is nothing but a small part of the conductor through which the current is flowing. Current element is given by product of length of the conductor and the current flowing through it. So, and current element is a vector quantity. Therefore, the Biot-Savarts law applicable for vector source. Point number 4. In Coulomb's law, displacement vector joining the source and the field point is considered. Here is a displacement vector. What is the displacement vector? You see here, we are having the path AOB and we are having the path APB. The path APB is the shortest distance between the Q1 and Q2. So, the path APB is nothing but displacement vector. It is the shortest distance. Displacement vector between the Q1 and Q2. In Coulomb's law, we consider displacement vector. Whereas in Biot-Savarts law, the magnetic field is perpendicular to the plane containing displacement vector R and the current element IDL. That means the direction of dV is perpendicular to the plane containing dl and R. Point number 5, Coulomb's law, the force between two charges, we consider displacement vector, that is F equals to K into Q1 Q2 upon R square. So between the two charges Q1 and Q2, we consider displacement vector between the charge Q1 and Q2. Whereas in case of Biot-Savarts law, we do consider angle theta. That is here is a current element and we want to find magnetic field here. So that magnetic field will depend upon angle between the displacement vector and the current element. So Biot-Savarts law is angle dependence. It depends upon the theta. It depends upon the value of theta. Therefore, Biot-Savarts law is an angle dependence. Whereas the Coulomb's law is independent of angle. It is just depending upon the displacement vector joining the two charges.